Ever wondered how vital electromechanical equipment is in hydropower plants? Well, let's dive into it. Hydropower plants, the unsung heroes of renewable energy, are a marvel of engineering. At the heart of their operation lies the electromechanical equipment. This includes the turbines that harness the kinetic energy of flowing water, the generators that convert this mechanical energy into electrical energy, and the transformers that prepare this power for transmission. But it doesn't stop there. A myriad of additional systems, such as control panels and lubrication systems, work in harmony to regulate power generation, ensuring it's safe, efficient, and reliable. These intricate parts and pieces, each playing their role, are the backbone of every hydropower plant. They enable us to tap into the immense power of water, converting it into electricity that lights up our world. Without these sophisticated pieces of equipment, harnessing the power of water would be a far-fetched dream. Before we dive into the erection process, let's understand the prerequisites. It all begins with site preparation. A well-prepared site, complete with robust foundations and accessible roads, sets the stage for efficient installation. It's akin to laying a strong foundation for a building. Without it, the entire structure could crumble. Safety, too, is paramount. A comprehensive safety plan should be in place. This includes not only protective gear, but also safety training, ensuring everyone involved is aware of potential hazards and how to avoid them. The use of safety equipment is not just a recommendation, it's a necessity. It's about creating a safe environment for everyone involved in the project. Finally, one must never underestimate the importance of access roads. These provide crucial connectivity, enabling the smooth transportation of heavy machinery and equipment to the site. With solid site preparation and stringent safety measures, we pave the way for a smooth and accident-free installation process. Now that we're ready, let's start with the heart of the plant, the main inlet valve, turbine, and generator. These components are the power trio, converting the kinetic energy of water into electrical energy. We'll begin with the installation of the main inlet valve, or MIV. First, we need to verify that the foundation for the MIV is correctly prepared as per the specifications. Once that's confirmed, we assemble and install the MIV, making sure it's properly aligned and sealed. The final step is connecting the MIV control system. This allows us to precisely control the water flow, which is crucial for efficient operation. Moving on to the turbine, the heart of our hydropower plant. Again, the first step is to ensure that the foundation is up to spec. We then assemble and install the turbine unit, following the manufacturer's instructions to the letter. It's essential to verify the turbine's alignment with the MIV and generator. Any misalignment can lead to inefficiencies or even damage to the equipment. Next up is the generator, the component that produces the electricity we're after. We begin by checking that the foundation is prepared as per specifications. We then assemble and install the generator unit, adhering strictly to the manufacturer's guidelines. As with the turbine, it's essential to ensure the generator is correctly aligned with the turbine and MIV. But we're not done yet. To keep our turbine and generator running smoothly, we need to install the lubricating oil system. This system comprises various components, including pumps, filters, and reservoirs. We install these components and connect the system to the turbine and generator for effective lubrication. We also need to wire and connect the system's electrical components, such as motor control panels and sensors. Now we need to install the transformers. These are typically located in designated transformer yards or buildings. We must ensure appropriate grounding and electrical connections, following electrical engineering standards to the letter. Next is the installation of control panels and instrumentation systems. These are usually located in the control room or other designated areas. It's vital to ensure all control systems are correctly wired and connected to the equipment. This allows us to monitor and control the operation of the plant. Finally, we lay and install power and control cables, ensuring they're properly terminated to the equipment and control panels. This step, often overlooked, is crucial for the safe and efficient operation of the plant. We round off the main components installation with switchyard works. This involves erecting and installing switchyard equipment like circuit breakers, switches, and protection devices. It's essential that the switchyard complies with electrical safety and grounding standards, and there you have it, the installation of the main components of a hydropower plant. Each step is crucial, and each component plays an essential role in converting the kinetic energy of water into usable electrical energy. It's a complex process, but by following the guidelines and standards, we can ensure a successful installation. These are the key components that convert the kinetic energy of water into electrical energy. The plant doesn't run on these components alone. There are other crucial systems too. Let's begin with the lubricating oil system. This system is like the lifeblood of our hydropower plant. It reduces friction, dissipates heat, and ensures the smooth operation of our turbine and generator. To install it, we begin with the components: the pumps, filters, reservoirs, and other associated equipment. These parts are connected to the turbine and generator to ensure effective lubrication. The electrical components, like motor control panels and sensors, are wired and connected as necessary. Next, we have the transformers. These are installed in designated transformer yards or buildings. Their job is to step up or step down the voltage as required, facilitating efficient power transmission. But their installation is not just about placing them in the right spot. We need to ensure appropriate grounding and electrical connections in accordance with electrical engineering standards. Moving on, we come to the control panels and instrumentation. Installed in the control room or designated areas, these systems allow us to monitor and control the plant's operations. All control systems need to be correctly wired and connected to the equipment. This ensures that we have full control over our plant's operations at all times. Finally, we have the instrumentation. These are the eyes and ears of our plant. They provide us with crucial information about the status of our equipment, such as temperature, pressure, flow rate, and other important parameters. These instruments need to be installed at strategic points and connected to our control systems to provide real-time data. These additional systems ensure that our main components run smoothly and efficiently. Each one plays a crucial role in the functioning of the plant. Without them, our main components like the turbine and generator wouldn't be able to operate at their full potential. So, while they may be called additional, they are, in reality, integral to the success of our hydropower plant. With all the major components in place, it's time to connect them. This involves the laying and installation of power and control cables. These cables are carefully routed through designated trenches or conduits, ensuring they are adequately protected and correctly placed. Once laid, the cables are then terminated, connecting them to their respective equipment and control panels. This ensures a seamless flow of power and data, making the entire hydropower plant truly interconnected. But our work doesn't stop here. We then move on to the switchyard, the heart of power distribution. Here, we erect and install essential equipment such as circuit breakers, switches, and protection devices. Each piece is meticulously positioned and connected, following strict electrical safety and grounding standards. This careful orchestration allows for the efficient and safe distribution of generated electricity, linking the hydropower plant to the grid. These connections make the plant a cohesive unit, ready for action. We're almost there, but we need to test everything before we go live. It's critical to carry out pre-commissioning checks, ensuring all connections are secure and settings are accurate. This forms the foundation of our commissioning process. Next, we roll into functional and operational tests. These tests are not just about checking if the equipment turns on, it's about making sure everything operates as intended under various conditions. It involves adjusting, fine-tuning, and verifying the performance of each component in the system. But the process isn't all about the machines. Safety is paramount. Therefore, we conduct extensive safety inspections to ensure the facility meets all safety and regulatory requirements. This includes checking safety gear, emergency systems, and electrical safety measures. These steps are not just precautionary measures, they are essential. They ensure that our plant is ready to produce power safely and efficiently. Our plant is ready, but our work isn't over yet. Now comes the crucial part: documentation, training, and operational handover. Detailed records of all installation procedures, tests, and commissioning activities are essential. They not only provide a roadmap of what has been done, but also serve as a guide for future inspections, maintenance, and even upgrades. But the machines don't run themselves. That's why training the operating and maintenance personnel on the operation and maintenance of the electromechanical equipment is vital. They are the ones who will keep the plant running smoothly, ensuring optimal performance and longevity of the equipment. Once these steps are completed, we move to the operational handover. After successful installation testing and training, the plant is handed over to the operations team. They take the baton from here, running the plant, keeping it in top shape, and ensuring continuous production. With these final steps, our hydropower plant is now ready to harness the power of water and convert it into electricity, contributing to a greener future.